A very warm welcome back to you, Rob, and thank you so much. Last week was so interesting when you gave us a kind of potted history of galvanizing and then briefly showed us how the actual coating mechanism of galvanizing works, or how the material layers up. So I guess we can say we know what galvanizing is and what it isn't. And I thought today it might be helpful if we could expand our conversation and discuss maybe some popular applications of galvanizing. So shall we start by looking at what you called last week general galvanizing and where that has application?
Thanks very much, Vanessa, and welcome to everybody. I guess there's a couple of things that it's always important to get the puns into place, so I can demonstrate how galvanizing shines. Okay, that's at least the first one we've got rid of. And hopefully I can also keep people's interest by bringing in a little bit of background information as well. But I think that if we look at the general galvanizing market, it is really a market that is completely ubiquitous. So we have everything from the gates that people would have, or on factory gates and the like, burglar bars, which might be an issue in South Africa. And then you go to real structures such as airports, bridges, multi-story car parks. The car park at Melbourne Airport, as an example, is a completely galvanized structure. So it's used in lots of structural applications. And maybe it'd be interesting to have a look at some of the local applications. And I guess the ones that people are familiar with would be transmission towers and the mining industry. And if we look at the mining industry specifically as the first port of call, a lot of the traditional mining cities, onto a better word, in South Africa, we're all familiar with the mining headgear. And in fact, there's one behind me here.
Yes, yes.
But what people don't seem to realize is that there's a significant amount of shaft steel work. And if you look at a deep level gold mine, that can be as much as 5,000 tons. And all of that steel has to get down the little hole. So it's then bolted together. And that particular market was opened up, I guess, in the mid-70s, primarily by the work of people like Walter Barnett and Michael Brett. And it eventually became the norm. And certainly, if you look at some of the newer mines, which would be, I guess, Black Mountain in Northern Cape, and some of the mines that are beginning to come on stream, all the above headgear, which is what you see, tends to be galvanized and often then painted for aesthetic reasons as well as corrosion resistance if required. The other market is just very interesting in terms of things like transmission towers. And you will remember that last week I said, well, often if you want to look at performance, you don't need to look far. And the transmission tower business in South Africa really boomed in the 60s and 70s. And in fact, it's fair to say that in those days, it was 50% of the market. I mean, so it was a huge market. And there were new galvanizing plants that came on stream. And I'm sure they will excuse me saying this, and some of them have very imaginative names like power lines. So the market was probably, a bit of a giveaway. And these lattice type structures, they didn't just sort of pop out of people's head. It was actually a design that was used very much in England in the very early 20s. And that design was the result of a design competition. It was won by an outfit called Milliken Brothers in the USA. And in fact, all the transmission towers that you see probably globally that are lattice developments are from some of those original designs. And what's quite interesting in the UK specifically is that people have become upset by the footprint of some of these large galvanized transmission towers. And as a result of that, they've gone into what we call the T-pylons. And these T-pylons also, the design was a competition. It was actually run by a company called Bijstrop in Denmark. So I mean, it is quite fascinating. And just another little snippet of information is that I use the word pylons because it's the word that is very common in England. And we forget about fashions. I mean, I'm not a rapper or whatever. It's sort of that's a bit beyond me. But in the 1920s, everything to do with Egyptology was really flavor of the month. And they discovered the Tutankhamun tomb in 1922, I think. As a result of that, that's why they came up with the name pylon, because they had two obelisks on the side of the entrance to Egyptian tombs, and the Egyptian word actually essentially is pylon, and they thought, well, the obelisks. So that's how it's just fascinating that there's peculiar history. So yeah, it was all the rage. It was the fashion in the 1920s, and I would say that as a result of that, that's probably in any developing country is the largest market is transmission towers. But it's used in general galvanizing is used in a massive breadth of any application where structural steel is used.
Well, one huge advantage I can see from a coating perspective is that it's much easier to get in all the nooks and crannies than it is with a brush. So I guess it does have that huge advantage if you're popping it all into a big giant, what did you call it last week, kettle, then you know that you're getting zinc everywhere. Rob, you've spoken about a lot of steel examples, and if you've got bits of steel, there's a common problem associated with that, and that's joining it all together, and the use of fasteners or nuts and bolts, and sometimes they don't work as they should. Would you like to talk through that challenge?
Yeah, that is a perpetual issue. It's not a new issue, and in fact, the number of times you will see, say, stanchions on a balustrade, and you think, well, this balustrade is galvanized, and you look at the bolts and you think, well, they don't look very in a very happy state. Nuts and bolts can be galvanized. It's a very similar process to general galvanizing. There's just a couple of tweaks at the end. But fasteners can also be Sheridized or electroplated. If you look at electroplating jet, you do not get the thickness of the zinc coating that you should get. And Sheridizing, there is certainly a standard for Sheridizing, and there are pluses and minuses with Sheridizing, but also you do not really get the same amount of coating thickness. So you end out with a compromise. And I think that's the problem, is that the fasteners should never be a compromise. And to use a good analogy, many years ago, I remember, and I think people who are involved in the structural business in general or have any encounter with welding will appreciate that the reason you choose the chemistry of the filler material in a weld isn't just so that it flows. I mean, we know that, but it's more to do with the fact that you really want the weld area not to be the anode in the galvanic couple. It's important, therefore, that the weld is not the weak point, and the same occurs with fasteners. So it is dreadfully important that when you have a bolted structure, that you do specify that you're going to use galvanized nuts and bolts, and that generally means then that the problem will go away, assuming the design. And it is purely based upon the thickness of the zinc that you can apply.
And of course, the challenge with that is that you also need to make sure that you've got somebody who knows what they're looking for to ensure that the bolts and nuts that are supplied are in fact what you think you're getting.
Exactly. It is critical, and I really can't emphasize it enough, because the fact that you've brought it into this discussion as a topic goes to show that we still have the same issue, and it really should not arise. It's all to do with the fact that it looks nice and shiny. And as I said, the galvanizing is nice and shiny at the beginning. The thing about the electroplating is it's nice and shiny, but it immediately, or not immediately, but you would then end up with rust rather than it going dark grey. So you have a problem.
Correct. Yes. Now, we did have a question that came in and is something I'm also interested in, and that is the performance of hot dip galvanizing underwater. Is that a possibility or not a possibility?
I think the best way I can describe that is in terms of things like Braithwaite tanks. And before everybody becomes sort of a little perplexed, the Braithwaite tanks are these steel plates that are bolted together. So in fact, it almost goes back to the previous comment. And you'll see them often then on a lattice structure. Braithwaite tanks have been used in South Africa for nearly 100 years. So yes, it can be used in water, but you have to know the quality of the water, as you would imagine. And again, I think there's many case histories of Braithwaite tanks. I know that the Galvanising Association has quite a good example of a tank in Johannesburg, quite close to the Supreme Court, and that's been there for many years. And in fact, what is interesting is that the very first galvanizing plant that was put up in South Africa in about 1950 was to actually galvanize these steel plates, Braithwaite tanks. So the short answer is yes, it can be used. And of course, we've got galvanized piping, that's been used for many, many years. And there's been developments in the piping from the point of view of going from a normal bolted connection, I'm talking about the large bore piping now, to simple things such as cable lock. So there are product developments that's still going on even today. And over the years, the specifications and standards have been revised to try and tweak things so you get better performance. But you are quite right in that it does depend upon the quality of the water. Field irrigation systems, which you'll see when you drive into the field, you'll see them everywhere, and they have also been for years. So there are many, many common examples, but I do have to emphasize that galvanizing works in what I would consider to be relatively benign water, but it's also used in the mining industry, pumping water out from the mine. So it will take fairly aggressive water. And there are a couple of key analyses that have to be made to actually make sure it will perform. Soft waters are not good for galvanizing. Generally, that means that the pH is a little too low, or you end up with almost sucking the calcium out. If there's very little calcium in the water, you need hardness of more than about 65 ppm of calcium carbonate. So I think that provided you have an analysis and the guidelines, which I prefer to go through next week, yeah, it will work. In terms of seawater, there are applications in seawater. It tends to be better if it's fully submerged than in the tidal area, as you would imagine. Right. That's really because of wet and dry, evaporation, concentration cells, and the rest. Quite a wide market for galvanizing in marine application, as an example, would be in the salmon fisheries business. So if you go to places like Chile, you will see a significant number. In fact, all the cages that are used in offshore salmon farming are actually hot dip galvanized.
There's a risk, I think, of assuming that a product that's been around since the mid to late 1800s means that product development has stagnated. Are there some examples you've got of meaningful product development that's occurred relatively recently?
There's three examples that I think illustrate the fact that people still are looking into, are there new applications. In the USA, the distribution pole, which is essentially 130 kV and below, is made out of hardwood. And the American Iron and Steel Institute spent a lot of work converting them from wood to using steel, galvanized steel. And we looked in Africa as to, well, could we do the same sort of thing? But the problem is that here, everybody uses cheap and cheerful grade 5 or grade 6 pine, which twists and warps and what else. And if you just replace that with a galvanized tubular structure, financially, you're out by leaps and bounds. And about, I suppose, 10 plus years ago, suddenly somebody said, well, why does the cross section have to be round? And everybody scratched their head and thought, well, nobody's ever asked that question. And in fact, what we then did is we looked at a round pipe, and if you squash that pipe, so you end out with this sort of almost like in the mining industry, they have these things called buntons, and so you have this round pipe that you squash like that. We then could take out 50% of the steel. But of course, I was happy because the surface area remained the same, so the amount of zinc that went in was identical. That's a really good example. And another example, actually by the same person, was if you decide you want to put up, say, the repeater stations for mobile towers, if you go into the middle of nowhere, carrying bags of cement and concrete and water is often an issue as well. And they came up with the idea of what's called an Astra base foundation, which is essentially, it's a bit like a child's sandpit. So you imagine a child's sandpit with where each part is sort of compartmentalized. So you just plonk this thing down, you fill the whole thing with sand, and then you can put your post up. So it's actually a foundation, but it's not a fixed foundation in terms of concrete. So
that's pretty clever.
Yeah, I mean, people have thought of all sorts of things, and coming to maybe an application that people won't be very excited about. But if you look at an automotive, and you look at a car, the trailing arms on a lot of cars now are hot dip galvanized. I must say that they're galvanized not to a thickness that possibly people would say that they want on a galvanized structure, but not many cars are lasting 100 years. So it's not a primary issue. I mean, really, you've just got to outlive everything else. Yeah, product development is still there, even in the general galvanizing business.
Well, that's good to hear. And aesthetic use of galvanizing, are there any applications?
Yeah, I mean, it's probably quite topical this morning, but if you go to the Santon Convention Centre, all the light poles there, and they're actually, if you look at them, they're actually quite fancy. And I mean, they were done as an architectural design. There's the solar trees at the Eastgate Shopping Centre. They're not just solar panels plonked on the top of the shopping centre. They actually are called solar trees. There's the Boomslang walkway at Kirstenbosch Gardens. Probably a couple of famous ones would be the Grand Arbor in Brisbane along the river. And then there's what I quite like just because of the name. There's the Singing Ringing Tree in the UK, and that is a series of pipes, but all at a different angle. So that as the wind blows, you get a different sound. So it actually makes a noise. Well, not a noise, and that's
music.
But yeah, and it's called the Singing Ringing Tree. So there's a lot of, I mean, they're the most esoteric applications, but there's also a lot of, it's used in a lot of architectural applications, really for effect. Another example I could think of would be the National Library in Pretoria. It is used in what some people would consider to be non-typical sort of applications for something that's, as you said before, just great. Aesthetic
as opposed to necessarily purely functional. Redirecting our conversation perhaps a little bit, we've spoken about where we can use batch process galvanizing, but last week, and in fact earlier, you alluded to continuous galvanizing, which I would imagine would include your zinc wire, maybe your, I don't know, zinc sheeting perhaps. Are there some uses and developments in technology there that have made significant changes in what's used and how it's made?
Yeah, I think that there's very little doubt that if I look at the heating operations within a general galvanizing plant, a lot of that I would say comes out of the steel business and the changes that have occurred in the steel business. And similarly, the actual general galvanizing product itself has come out of the continuous galvanizing industry. And that's really because the drivers there have been the onerous applications of things like the auto industry. The reason why steel is still used in the car and it weighs a lot less, and we have little jokes about we're all driving tin cans, is the fact that we've managed to keep the weight down, but we're using high strength steels. And galvanizing those steels requires some fairly fancy footwork. So there's been a lot of development in terms of the galvanizing process in order to meet that need. And just to put it in perspective, some of these lines can be moving at 200 meters a minute, which means that the steel coil, as it's uncoiled and goes through the process, is in the zinc kettle for less than a second.
Wow.
So you have to have some fairly good technology to actually get a product that is usable. But because it's continuous galvanizing, it is a thinner coating. But in addition to that, it's more of a zinc coating than the zinc alloy coatings that we discussed last week. And therefore, you can form it and do what else you want to do with it. And if you look at things such as tailored parts in the auto industry, where you optimize the thickness of the material for different parts. So you go around, say, the door area of a car, you don't need, the pillar has to have a certain amount of strength, not just structural strength, but impact strength in case of an accident or what else have you. But you may not need that when you go into other parts. So that there's a lot of different thicknesses of material all joined together. And when you actually have this, again, it's got to be weldable. You've got to be able to weld these different thicknesses, and there's some serious technology going into that. And the spin-offs out of that have been that if you look at the continuous galvanizing industry, we have what's called GI, which is the standard zinc coating that I've really referred to, which is nice and shiny. You have the GA, which is galvanneal, which is dull gray because you can actually grow the alloys through. And then the recent things which have been looking very much at the cladding and the roofing market rather than going specifically into the auto industry, you've got the zinc 55 aluminiums, which came out of Bethlehem Steel in '72. You've got the zinc 5 aluminiums, the Galfan type product in 1981, which is used mainly for wire in South Africa. And just to digress into that, there is a local producer who's essentially an agent for an Italian company. The company, I'll mention the company's name, it's called Macaferri, and they do a lot of gabions, which are these basically lots of big rocks in a wire cage, which are used to hold up embankments and the rest of it. If you look at the cow train near the Marlborough station, you'll see the use of gabions. And the wire, for want of a better word, and it's quite thick stuff that holds all that together, is a galvan wire. So that's a 5% aluminium. More recently, you've got things like zinc, aluminium, magnesium, or the ZAM alloys. A typical example of that here would be what we call magnelis, and that's used widely for construction in Japan. And if we look at things like the continuous marketplace, continuous galvanizing in South Africa goes back to the introduction of the first plant, as you can imagine, which was again in the 1950s in what was the score in those days, now is ArcelorMittal. And then about 15 years ago, Safal Steel introduced the zinc 55 aluminium locally. And both of those products are also available in color. So you've got a Chromodec product, which people are probably very familiar with because that's been around for a long, long time. And there have been sort of tweaks and improvements over the years in terms of the coating systems. And then you've got the Color Plus product from Safal Steel. So we really have all the availability of those sort of steels here. There's also Electrogalv. Toyota use Electrogalv, BMW do not, and I don't want to get involved in the arguments between the two products because, as I said initially, on a continuous coil, it's always a thinner coating anyway, for lots of very good reasons.
And obviously, from what you've just said, in South Africa, we have a number of galvanizers who play in our market.
Yeah, in terms of continuous galvanizing, there are those too. And the various roofing profiles are available. It's a very competitive market. A good example of, say, the zinc 55 aluminium would be the Gateway Shopping Centre. That particular centre is quite interesting when you look at just galvanizing in general, because you've got it's actually Galvalume, because that came from Australia before the Safal plant was established here in South Africa. But also they have these very tall panels on the outside of the building, which if you look really carefully, you can see that it looks as if the walls are almost prefabricated. And in fact, they are prefabricated. And they're called tilt panels. And they are very thin concrete, but the framework inside of these is all galvanized. And it's because the things will bend. And as a consequence, when you lift them up, and as a consequence, you will get micro cracks. And the last thing you want is for the rebar to actually corrode. So as a result of that, the reinforcing is galvanized. And globally, there is a slow move now towards the use of galvanized rebar. And that's really because if you were to look at the structural steel market globally, it's in the order of about 150 million tons. And strangely enough, the rebar market is almost exactly the same size. Wow. And we've now got to the stage where people just don't have money. So if you look at governments, they don't have the money often to maintain some of these things. So a little bit of extra upfront means that you can put in a corrosion-resistant rebar. And yes, there are competitive materials, but you can put in the corrosion-resistant rebar and you get hopefully a longer life.
Excellent, Rob. Just as we close off, future applications for hot dip galvanizing? Do you think there's still a future for it?
Yeah, I think, I mean, just to lead off from what I've just said, is that if you look at the whole point of longevity, and I think that there's been a revisiting of that. I mean, ignoring things like circular economies and just the sustainability, which everybody wants to leap on. We are in a position now where people are saying, well, we want things to last longer. As I said, governments don't have money, and the public-private partnership system, which will become more and more of the norm, you will end out with a lot of new applications in things like bridges, as an example. I mean, in the USA, there's 600,000 bridges that require attention. Some of them have collapsed quite spectacularly. But if you look at marine applications, ports and harbors, we've used galvanized now for over 50 years in the bridges in the Keys, in the Florida Keys. So assuming that the hurricanes don't get too wild and it doesn't get washed away, then that structure is still there. And a couple of other interesting things, just to sort of wrap up, is one of them is nobody realistically thinks that these feed-in tariffs are only going to be in existence for 20 years. So they move towards solar and renewables, and the business model on which they're based, whereby I build it and then I've got a 20-year contract. Those contracts are likely to be renewed. And sure, as top parts of the engineering, solar panels perhaps will be replaced, the actual base structure will have to remain. So there will be markets, substantial markets in that. And another exciting development, which is sort of really relatively recent, and I don't know how much exposure you've had to those, but funny things such as if you go into Brazil, you'll suddenly find in Sao Paulo, there's a car park, and when you drive into the park, it's just, you think, well, this is ridiculous, because the whole thing is the size of the car. And you get out of your car and you hand the guy the keys, then your car disappears. And there's a complete structure, and your car is, for want of a better word, posted into a parking place. And then when you come back, they press a button and your car is refound and then sort of reappears in what just appears to be almost a domestic garage. And that's part of the new era of smart cities. And smart cities are essentially, when you want to dig a hole, you don't actually wreck the road. What you do is when you design these new building areas, construction areas, or cities, what else? You design the whole infrastructure and the service conduits such that you don't have to disturb what's above ground. The new, is it 100-kilometer or whatever the thing, the building in Saudi Arabia, that will all be a smart city. And the storage of water underground, huge move in countries such as China to look at these large underground storage systems, which are galvanized. And so you actually have underground reservoirs which don't have the evaporation problem, and sometimes don't have environmental concerns that people have of burying villages and forests. So yeah, I think that there's very little doubt that the general galvanizing and the continuous galvanizing markets are here to stay and have a fairly rosy future, or a very rosy future.
Well, thank you, Rob. This has been an absolutely wonderful discussion and series. Thank you.